Hi, this is Christopher Boucher, and I'm going to review an example of a standard normal continuous probability distribution. And it's one of the easier ones when we get into, before we get into hypothesis testing, and before we get into sampling distributions, and before we get into t-distributions. It's a basic population distribution, and we're finding the probability. So we're not solving a hypothesis or anything like that. We're just finding the probability. Okay, so nationwide, people who ride a bus wait an average of 16 minutes with a standard deviation of 3. What is the probability one will wait 20 minutes or more? So let's write down what we know. We know that mu, or our population mean, is 16, and our population standard deviation is 3. And we are going to write down our probability statement, which is we're solving for p is our x is greater than or equal to 20. Okay, the direction of our inequality is very important because it points towards our area of interest. When we move on to hypothesis testing, it's going to point to the rejection zone. But for now, it's pointing towards our area of interest, and that's what we're looking for. So we always want to draw, it's very important, people try to skip this step. Always want to draw our distribution because it has to logically make sense when we're doing this. It will help us identify the parts that we're solving for. So we draw the middle. We do mu equals 16. Now, our inequality is pointing to the right. So we go, it's pointing right here to that tail. So this is what we're solving for. We have to calculate the probability of this area. Okay, now let's get started. So we're going to use the z distribution in this case. This is a population distribution, so we can go straight to the z, and we're going to standardize our data. And once we standardize it, we go to the z distribution table. Then we can easily solve the probability that we're looking for. So the formula we're working with is may look familiar to many of you. So then we go, we fill it in. So our x in this case, our x is R20. Our mu is 16, and our standard deviation is 3. And when we solve this, we end up with negative, I believe it's negative, oh no, not in this one. Next one. This is 1.33. Yeah, it's not negative. When we go on the other side, we end up with a negative value. So it's 1.33. So this is only our z value. So we need to go look this up on the table. We get out our handy dandy z table. A little bit of reflection from the lamination. But we're looking for 1.33. So what we do, let me zoom in a little bit. We find 1.3 down the side, and we go over, I'm going slow because I'm looking at, okay, so it's 1.33. So it's this is the area under the curve for half of it. Now this is an alternative z-score table, so it only has half of it. It's not cumulative, it's just one side. So this whole table only adds up to 0.5 for a total. So our answer, or our probability of that one side, is 0.4082. 0.4082. So we go back, and this value turns into 4082, yes. And that 4082 is the value of this right here. So if we know this is 0.4082, This is 0.5. I'm going to back it up just a little bit. So once we know that this is 0.5, this is 0.4082, what we do is we can solve this. So we take 0.5 plus 0.4082, we add them up, and we end up with 0.9082. And then, because now we've solved this area, the probability for this area right here, that's not exactly what we want. We want the other part. So all that we have to do is we take 1 minus 0.9082, and we end up with a small figure, which is 0.0918. It's a little hard to see that 9. 0.0918. And that is our area right here. That is the probability for waiting 20 minutes or more when the average is 16 minutes with a standard deviation of 3. Now you can look at it another way. Essentially what we solved right here is we solved 20 minutes or more. So the other side of the coin is, what would it be if we were to wait less than 20 minutes? So less than 20 minutes is this value right here. So we can flip-flop this however we want, but for our answer it is 0.0918, and then less than 20 minutes would be 0.9082. Remember, this can only equal 1 when we add this all up. Okay, thank you.